In the previous video, we discussed about the following topic: the definition of a function pointer, declaration, passing function pointer, and returning function pointer from a function. In this video, we will discuss further topics like function pointer array, comparing function pointer, and casting function pointer. So let's look at the first topic, function pointer array. If you created a function pointer, you can also create a function pointer array. Once you define a function pointer using type def, you can simply declare an array of that particular function pointer using the function pointer you declared earlier. Here you can see funcPTR is a function pointer which can actually point to a function which take two integers as argument and return another integer. Using this predefined function pointer, I can create an array of that kind of function pointer just using the similar syntax we use for integer pointer arrays or character pointer arrays. Here you can see I just type funcPTR space the array name and in the square bracket, like we do for any other array of pointers, I define the size. That's it. Let's take a look how this function pointer array works in this code. It's very simple. Here actually I use this function pointer array to store the address of each function. Basically in this init funcPTR array function, you can see here I am assigning the address of add and sub function to this function pointer array's location, where you can see I am passing actually a plus character. Don't confuse by seeing this line of code. It's very simple. When I pass or use this plus character inside the array index, it actually converts this plus character into its corresponding ASCII code, and this plus character will be replaced by the ASCII code. For example, if this plus character ASCII code is 78, this line will read like this: funcPTR of 78 is equal to add. Suppose if the ASCII code of minus is 58, this line of code will be read like this: funcPTR of 58 is equal to sub. That's it. It's very simple. If you take a look into the evaluate array function, we can see that it take a character and two integer. In the main function, we can see that when we are calling or invoking this function, we are actually passing plus sign and a minus sign along with two integers. So it's very simple. The opcode local variable contain that particular character denoting the corresponding operation, and in this eval function, we will first declare a function pointer from the type we created earlier, funcPTR, then assign a function's value to that particular function pointer using this funcPTR array, because we are trying to get the value of funcPTR array of opcode. This opcode contain a character which denote a particular operation. So this will be replaced by the plus character in the first call of this function, and this in turn will return the address of add function, which is in turn stored in the operation function pointer, and using that function pointer we can call the add function. Here you can see an additional code actually which is similar to the above code, but which simply replaces the above two line of code. So let me comment out it. I will explain that code later. First of all, we will take a look into the output of this code. So we are going to compile and see the output. Or you can see we get 40 and 20, which should be the result of these two lines of code. Here you can see we are actually declaring an additional local function pointer inside this eval array function. We can replace these two line of code with a single line of code, as you can see here. It's very simple. We just use this funcPTR array we created, that global function pointer array we created, to get the address of a particular function. So I am using funcPTR array and passing the opcode as the index, which will in turn return add function's address on the first call and sub function address on the second call. Once you get that address, we can actually use the parenthesis to invoke that function and pass the corresponding integers to get the desired result. So this will also work fine. So we will write to that file and we can actually execute. So let's change the values we are actually passing. Here I will change it to 50, and here I will change it to, let's say, 45. So we should get actually 60, and 45 minus 10 is equal to 35. We should get that two result. So if you compare or run again, we will get 60 and 35. Next question will be how we can declare a function pointer array alone without declaring a function pointer at the first stage. Here you can see that first I defined a funcPTR function pointer type, and using that function pointer type I declared or created a function pointer array. Is there a way to actually not declare a function pointer in the first place? Yes, there is. We can use this particular syntax over here. It's very simple, but this syntax can be confused with the syntax for pointer to a two-dimensional array or multi-dimensional array. I will explain that later in this video, and I think I mentioned about that topic in the previous videos. So here you can see the syntax is somewhat complicated, but it is self-explanatory. If you know how to create a function pointer, we basically use a parenthesis and put the pointer function name inside that parenthesis. That's the way we create a function pointer. That's not only the way, we should also take care about the parenthesis after the function pointer, because this parenthesis with the argument list denote that it's a function pointer. Here you can see that creating function pointer array is very simple without using a type def. It's very simple because the only thing you need to do is just declare a function pointer first. Then you can make this particular function pointer an array by adding an index and giving the size inside that. That's it. That's what I did here. You can see it. And now let's check whether this will work or not. So I commented out of the lines where I use this funcPTR function pointer. Instead I am only using the function pointer array created using the normal syntax. So again we will change the value here, and here let me add 15 actually. So this should output like 110 and 60 when we run this code. Let us check whether that's true or not. Here you can see we get the desired result 110 and 50. So like I said, this syntax is little bit cryptic because if you know how to declare a pointer to a multi-dimensional array, so we will take a look into that now. Now I am going to comment out all other lines, and let me uncomment all these lines. Here you can see I declared a two-dimensional array which contains 2 rows and 3 columns, and I created an pointer to that multi-dimensional array. So if you take a look into the syntax of creating a pointer to a multi-dimensional array and a function pointer array, there are some kind of similarities. Don't confuse it with the syntax of multi-dimensional array pointer. A function pointer array always will have this parenthesis which denote the argument of the particular function pointer, and when we create array of a function pointer, we usually define the size inside the parenthesis where we usually give the function pointer name. So this is one major difference between creating pointer to multidimensional array and a function pointer. So you should take care of that. There is a chance that you may put this size of this function pointer, that is this 128, outside this parenthesis. That may not work. So don't do this. This is utterly wrong, and this is the right way to do it. Okay, that's it for this video. I hope you understand how to use function pointer array. You should take care of the syntax because the syntax can be a little bit cryptic. That's why in the first place itself I encourage you to use type def, and then once you created a function pointer using type def, you can use that particular function pointer to create the array of that type. It's very easy. So I will see you in the next video.